Have you ever experienced the joy that comes with solving a problem? Scientists wish they were in that position right now, but they're actually scared by the solution they derived for a long-standing paradox known as the Fermi Paradox about aliens. What is the paradox all about, and why are scientists scared about the solution? Follow along as we dive deep into why scientists that solve the Fermi Paradox are not happy about the answer. Enrico Fermi was not even known for his work as an astronomer during his lifetime. His achievements were in theoretical and experimental physics. He is best known for his contributions to the development of quantum theory, nuclear and particle physics, and statistical mechanics, as well as his work on the advancement of the first nuclear reactor. In 1938, he received the Nobel Prize in Physics for his discovery of new radioactive elements produced by neutron radiation, as well as the discovery of nuclear reactions caused by slow neutrons. However, Fermi's name has now been forever associated with aliens through the Fermi Paradox. The Fermi Paradox was invented by the Italian-American Fermi. He is said to have had the idea while having lunch with colleagues in 1950 when he asked, "Where is everybody?" Given our planet's young age in comparison to the universe, he wondered if we should have expected someone to visit us by now, but there was no evidence of that ever happening. Sadly, Fermi died 4 years later in 1954 at a relatively young age, so he didn't have much time to think about the question. However, his ideas sparked entire fields of science in the hopes of finding a solution, including the search for extraterrestrial intelligence, SETI. Fermi realized that with a modest amount of rocket technology and an immodest amount of imperial incentive, any civilization could rapidly colonize the entire galaxy. Every star system could be brought under the wing of an empire in a matter of tens of millions of years. Tens of millions of years may appear to be a long time, but it's actually quite short in comparison to the age of the galaxy, which is roughly 1,000 times longer. One of the scientists that tried to pick up from where Fermi stopped was Michael Hart, who penned a paper explaining the absence of extraterrestrials on Earth. He proposed that this fact is best explained by the hypothesis that our galaxy contains no other advanced civilizations. He did note, however, that more research in biochemistry, planetary formation, and atmospheres was required to narrow down the answer. Hart contended that intelligent aliens could have visited Earth at some point in the past unless they began their journey less than 2 million years ago. He believed that the apparent lack of such visits was most likely due to a scarcity of intelligent aliens. However, he also provided 4 other explanations for why we have been apparently left alone by aliens. The first was that aliens never visited Earth due to a physical difficulty that makes space travel infeasible, which could be related to astronomy, biology, or engineering. You will quickly agree that we humans have the same problems with space travel. Another explanation is that aliens have simply chosen not to visit us. Their loss, I guess. Or aliens cannot reach us because advanced civilizations beyond Earth arose too recently and still have a lot of growing up to do. The last explanation is aliens have visited Earth before, but we did not see them, which would make the aliens masters of evading detection. Other researchers have advanced Hart's ideas. These include Frank Tipler, a professor of physics. He published a paper on how to obtain resources for interstellar travel, which he proposed could be accomplished by having some kind of self-replicating artificial intelligence move from star system to star system, creating copies of itself as it went. Tipler contended that because no evidence of such advanced machinery has been discovered on Earth, we are most likely the only intelligence out there. In the 1980 paper, he also stated that those who believe in extraterrestrial intelligence are similar to those who believe in UFOs because both groups believe that we are going to be saved from ourselves by some miraculous interstellar intervention. Extraterrestrial intelligence remains a hot topic, with multiple papers published each year by various research groups, and the ongoing exoplanet revolution has bolstered the notion that advanced civilizations may exist beyond Earth. In fact, the discovery of exoplanets makes it harder to argue we are alone in the universe. The universe is enormously large and old. Data from various telescopes show that the observable universe is about 92 billion light-years across and growing faster and faster all the while, and separate measurements indicate that it's approximately 13.82 billion years old. So alien civilizations have had plenty of time to emerge and spread, but they will almost certainly have to cross a vast cosmic chasm to reach us. When Fermi made his famous remark, scientists only knew about planets in our own solar system. However, since then, things have changed a lot. In 1992, astronomers discovered worlds circling a pulsar, a superdense stellar object. This was followed a few years later by the discovery of the first exoplanet orbiting a sun-like star. There are now thousands of confirmed exoplanets, with more discovered each year. The sheer number of alien worlds suggests that life may exist in abundance throughout the universe. Scientists will eventually be able to probe the chemical compositions of some nearby exoplanets' atmospheres using more advanced telescopes. However, nearby is a relative term. The nearest known exoplanet, Proxima b, is about 4.2 light-years away, or roughly 25 trillion miles, or 40 trillion kilometers. The ultimate goal is to learn how frequently rocky planets form in their parent star's habitable zone, which is traditionally defined as the range of orbital distances in which water can exist on a world's surface. However, habitat is more than just water. Other factors such as the activity of the host star and the composition of the planet's atmosphere must also be considered. And there are other reasons why the traditional definition of the habitable zone is increasingly seen as overly simplistic. Ice moons in our own solar system, for example, Jupiter's Europa and Saturn's Enceladus, are far beyond the habitable zone but may still harbor life in their subsurface seas. Despite these caveats, though, there appears to be plenty of habitable real estate available out there in space. According to a study that used data from NASA's Kepler Space Telescope, 1 in every 5 sun-like stars has a roughly Earth-sized planet orbiting in the habitable zone. Kepler scientists published a planet bonanza of 715 newly discovered worlds a few months later. Many of these planets were confirmed using a new technique known as verification by multiplicity, which is based in part on probability logic. Objects seen crossing a star's surface or tugging at it gravitationally are more likely to be planets than companion stars, because a companion star in close proximity would destabilize the entire system over time. However, sun-like stars are in the minority in our galaxy. Roughly 3/4 of Milky Way stars are small, dim burners known as red dwarfs. Astronomers have discovered several rocky worlds circling in the habitable zone of red dwarfs, including Proxima b and 3 planets in the TRAPPIST-1 system, which is 39 light-years from Earth and contains 7 rocky worlds in total. However, it is unknown how habitable such planets are, because red dwarfs are extremely volatile, especially in their youth. As a result, stellar eruptions may quickly blast away the nascent atmospheres of young habitable zone red dwarf planets, making it extremely difficult for life to establish itself. Researchers, however, are getting more tools to do this type of work. For example, NASA's Transiting Exoplanet Survey satellite, TESS, successfully launched and quickly took over from Kepler, which has since retired. And the new $10 billion James Webb Space Telescope will look for potential biosignature gases in the atmospheres of nearby exoplanets, among other things. There is also the Plato, or Planetary Transits and Oscillations of Stars mission of the European Space Agency that's scheduled to launch in 2026. And perhaps the most ambitious of them is the Breakthrough Starshot. It aims to study Proxima b and other nearby worlds up close with swarms of tiny laser-sailing nanoprobes. If technology advances as planned, the first interstellar robotic craft could launch around 2050. Such missions and instruments will aid scientists in deepening their understanding of astrobiology, which is still in its infancy. We don't even know if there are life-hosting worlds in our own backyard, for example. Microbes can survive in extreme environments, which suggests that microbial life may exist on Mars, Europa, Enceladus, and the giant Saturn satellite Titan. But we haven't explored any of those worlds thoroughly enough to be certain. One of the notable attempts to solve the Fermi Paradox is Drake's equation. It is used to calculate the number of communicating civilizations in our galaxy, or to put it another way, the chances of discovering intelligent life in the Milky Way. The equation, first proposed by radio astronomer Frank Drake in 1961, multiplies several variables to calculate the number of communicating civilizations. It is usually written as such. where n equals the number of detectable electromagnetic emissions from civilizations in the Milky Way galaxy, r star the rate of formation of stars suitable for the development of intelligent life, fp the fraction of those stars with planetary systems, ne the number of planets per solar system with an environment suitable for life, fl the fraction of suitable planets on which life actually appears, fi the fraction of life-bearing planets on which intelligent life emerges, fc the fraction of civilizations that develop a technology that releases detectable signs of their existence into space, and L the length of time such civilizations release detectable signals into space. However, don't expect to get a real figure using this equation. The problem, at least for the time being, is that astronomers don't have firm numbers on any of those variables, so any calculation of the Drake equation is only a rough estimate. However, advances in some of these fields have given astronomers a better chance of finding an answer. But are there more realistic solutions or explanations for the Fermi Paradox? In truth, there have been several. For example, scientists studying data from the Hubble Space Telescope and the Kepler Space Telescope concluded that Earth was most likely an early bloomer. The researchers discovered that only 8% of all potentially habitable worlds in the universe existed when Earth formed about 4.5 billion years ago. So one possible explanation for the paradox is that the aliens will arrive, but not for a while. We will surely be here to receive them. Or perhaps life is too fragile to last long. According to a study, the early part of the history of a rocky planet can be very conducive to life, which may commonly emerge starting 500 million years or so after the planet cools down and liquid water becomes available. The history of our own planet would appear to support that conclusion. There is evidence, disputed though, that life first appeared here around 4.1 billion years ago and was definitely established by 3.8 billion years ago. However, those good times may not last long due to a runaway greenhouse effect as occurred on Venus many years ago or other climatic changes. Maintaining life on an initially wet, rocky planet in the habitable zone may be like trying to ride a wild bull due to early heat pulses, freezing, volatile content variation, and runaway positive feedback. The majority of life is lost. Life may be rare in the universe because habitable environments are difficult to maintain during the first billion years, not because it's difficult to start. Or perhaps the bottleneck occurs much later. A number of thinkers have proposed that civilizations tend to die out soon after becoming technologically competent because they inevitably facepalm. Earth once again lends some support to this hypothesis. During the Cuban Missile Crisis in 1962, humanity came perilously close to nuclear war, and we may be on the verge of annihilating ourselves and much of the rest of life on the planet right now due to climate change. And there are numerous other factors to consider. For example, NASA's New Horizons mission to Pluto planetary scientist Alan Stern recently proposed that the most common life-hosting environments in the Milky Way galaxy may be buried oceans like Enceladus and Europus's seas. But organisms that evolve in such environments may be unlikely to develop spacecraft, which is literally rocket science. Indeed, many of them may be blissfully unaware that there are other worlds to explore. Alien psychology could also play a role. There may be many advanced alien civilizations out there, but the majority of them have no desire to communicate with us or visit Earth. Perhaps Earth and its inhabitants are simply not interesting enough for them to play with, and will not be until humanity demonstrates enough intelligence and merit to be admitted to the Galactic Club. Yeah, we may have to get over ourselves. We might think humans are the best thing since sliced bread, but aliens beg to differ. Or perhaps most intelligent aliens keep quiet as a general rule, fearful that making contact with their cosmic neighbors will result in their enslavement or annihilation. A number of researchers, including the late Stephen Hawking, have argued that humanity should not actively advertise its presence. Then there's the logistical challenge of tracking down intelligent aliens. It is by no means an easy task. The universe is vast and extremely old. Humanity has only been around for 200,000 years, and we've only been listening for possible extraterrestrial radio signals since 1960. so the chances of us overlapping in time and space with a detectable alien civilization don't appear to be great. Perhaps the most terrifying explanation for why we haven't heard from aliens is the dark forest theory by Liu Cixin, a fiction writer. He published a book that addresses concerns about interacting with potentially hostile alien life. Here are the basic ideas behind the dark forest theory. 1. Every living thing wishes to be alive. 2. There is no way of knowing whether other life forms can or will destroy you if given the opportunity. And 3. In the absence of guarantees, the safest option for any species is to annihilate other life forms before they can do the same, survival of the fittest on a cosmic scale. Because all other life forms are presumably risk-averse and willing to do anything to save themselves, any contact is risky, as it almost always results in the contacted race wiping out whoever was foolish enough to reveal their location. As a result, all civilizations attempt to remain radio silent. Here is an illustration from which the theory's name was derived. Imagine the universe is a foreboding forest. Every civilization is an armed hunter stalking through the woods like a ghost, gently pushing aside branches that obstruct the path and attempting to tread silently. Even breathing is also done with caution. And the hunter must exercise caution because there are stealthy hunters like him everywhere in the forest. If he comes across another life, another hunter, angel or demon, a delicate infant to a stumbling old man, a fairy or a demigod, he only has one option: open fire and eliminate them. This theory has the advantage of affecting only one of the variables in the Drake equation, the one that is most open to speculation. And it also does not necessitate broad assumptions about how all alien civilizations behave, because a single advanced race acting in this manner would be sufficient to cause the observed situation. This would also explain, despite having the ability to detect mundane alien radio signals for over a century, we have yet to find any. Just as we unintentionally send radio signals meant for us into space, another civilization is likely to do the same. One possible explanation is that other civilizations are so afraid of being discovered that they deliberately avoid sending out any radio evidence of their existence. It does, however, assume that other species have a similar risk aversion and reasoning process as we do, or that there is a single civilization out there killing off anyone who they believe can harm them. It should be noted that this is a significant assumption. But what is so dark about this theory so as to make it terrifying is that for nearly a century we have been screaming our existence to the universe. Any aliens within 100 light-years of us would be bombarded with radio signals from our direction, and we might have a problem if we have reason to avoid informing aliens about ourselves, as Stephen Hawking believed. So why haven't we heard from any aliens? If this solution is correct, they are purposefully hiding in space to avoid death. So should we also stop broadcasting our existence to the universe, or would alien life be nicer than we've been in the past? Like Arthur C. Clarke said, either we are alone in the universe or not, but both possibilities are equally terrifying. Let's hear what you think about aliens invading the Earth in the comments section below.